In this video, I am going to explain you about Transmeta's Crusoe processor. The Transmeta is nothing but a company's name, and Crusoe processor is the name of the processor. See here, the Transmeta's Crusoe processor is an interesting example that demonstrated the process of high performance with remarkable low power consumption can be implemented as a hardware software hybrid. Means the Transmeta Crusoe processor is the best example in order to get the high performance with low power consumption. It is a hybrid model, means it is combined with both hardware and software. See the next point, the approach is fundamentally software based, means here the complex hardware is replaced with the software. Means here we have software, but here we have hardware, but it is a little bit amount of hardware is required in Transmeta Crusoe processor. If any complex hardware is required, that is replaced with the software in Crusoe processor. That achieves the large power saving by visualizing the x86 CPU with a hardware software combination. Means x86 means x86 is nothing but a generally 32-bit CPU. For x64, that is 64-bit CPU. The x86 is nothing but a architecture. The architecture that is used to build a Transmeta Crusoe processor is x86 architecture. Okay, the Transmeta engineers has drawn a line between hardware and software such that hardware part is relatively simpler and high speed. Means we have hardware part in Transmeta Crusoe processor. The hardware part is very less or relatively simple and high speed, but much less power hungry, very long instruction word engine. The hardware part in Transmeta Crusoe processor is less power hungry. The hardware that is known as very long instruction word engine. The hardware part that is used in Transmeta Crusoe processor is very long instruction word engine. That is nothing but VLIW engine we are used in Transmeta Crusoe processor as a hardware. That is very simple and high speed. Then on the other hand, the complex task of translating the x86 instruction into instruction of the VLIW is performed by a piece of software. Means the hardware part that is very long instruction word doesn't understand the x86 instructions. Means the x86 instruction is a high level language instructions. That high level language instructions doesn't understand the VLIW engine. It is required to translate this x86 high level language instructions into the machine level language instructions. Means that machine level language instructions are in a binary code. We need to transfer these x86 instructions to the hardware understandable language instruction, that is nothing but machine level languages. In order to transfer these instructions, x86 instruction to VLIW instructions, we are using a software that is known as code morphing software. That is nothing but a CMS. See here, that is code morphing software. This is used to translate the x86 instructions to the instructions of the VLIW. x86 instruction is nothing but a high level instructions. Instructions of the VLIW means hardware understandable instruction, that is known as a machine level language instructions. We need to transfer this by using the code morphing software. This is the main advantage. The Transmeta Crusoe processor has a main advantage in terms of power consumption or speed related to other x86 processor is this code morphing software. In this we are using a code morphing software in Transmeta Crusoe processor. Then we will see what is the hardware in Transmeta Crusoe processors, then what is the software, and what are the advantages compared to other processors. We will see that one. See here, this is the hardware unit. This is the block diagram structure of the hardware unit for a Crusoe processor. See here we have two integer blocks. One is floating point unit and integer ALU. These two are the integer blocks, and lower store unit, this is nothing but a memory unit. Then this branch unit is nothing but in order to connect any hardware to this of Transmeta Crusoe processor, we are using this branch unit. This is the branch unit. Then see here, it is a x86 architecture. This x86 architecture is set into 28-bit molecule. Total this instructions is set into 28-bit molecule. Then these instructions are divided into sub-blocks. The sub-blocks is called as atoms. See here, these are the sub-blocks: FAD, YAD, LD, BRCC. These are the sub-blocks. This entire 128-bit molecule is divided into sub-blocks. This FAD is nothing but a floating point adder. Then this is a normal adder. Then load, LE is a load, BRCC is a branch if carry cleared. This 128 module is 128 bit molecule is divided into 4 sub blocks, that is called atoms, 4 atoms. This entire atoms is connected to the functional unit in a parallel manner. See here, it is connected to the functional unit in a parallel manner. This is the structure of a Transmeta Crusoe processor hardware. Then see here, we will see the structure of a other superscale out of order architectures. Means this structure is useful for a Pentium 1, Pentium 2, Pentium 3 processors. We will see this architecture also. Then compare this architecture with the Transmeta Crusoe processor architecture. Then we will see the what are the advantages and what is the disadvantages. See here, this is nothing but a Pentium architecture. This is also x86 architecture. The Transmeta Crusoe processor, the previous one, it is also a x86 architecture, and this is also x86 architecture. See here, what is the difference between this superscalar out of order architecture. This architecture is used in Pentium 1, Pentium 2, Pentium 3 processors. We will see the comparison. See here, in this the x86 instruction is transferred to the micro operations. The x86 instruction is transferred to the micro operations. Means this high level language is transferred to the mission level language, then given to the dispatch unit. In order to transfer this high level language to the mission level language, we are using 2 blocks, that is superscalar, decoder unit and translating unit. These 2 units transfer this high level language into mission level language, then gives to the dispatch unit. This dispatch unit is divided the micro operation coding and gives to the functional unit. Similarly for Transmeta Crusoe processor, we have 4 functional unit. In this also similarly we have different functional unit in this functional unit blocks. According to the functional unit, the code will be dispatched here by the dispatch unit. Then again the output of the functional box will take into the in order retired unit. This in order retired unit converted this micro ops into again x86 instructions. Means this mission level language is again converted into the this mission level language is again converted into the high level language. First the high level language is converted to mission level language, then this is dispatched to the functional units, then the mission level language is converted to high level language and gives to the x86 instruction. This is the operation for a superscalar out of order architecture. Then see here the comparison table for a superscalar out of order architecture. Means this architecture is used in a Pentium 1, Pentium 2, Pentium 3 processor with the Transmeta Crusoe processor architecture. These 2 are x86 architectures only, but we have some difference. See here, see the process. First of all, see the process for the Pentium 1, Pentium 2, Pentium 3, and this last 2 is the Transmeta Crusoe processors. First one is TM3120, the second one is TM5400. These 2 are the Transmeta Crusoe processors. See here the architecture here. The process in this is less in the Transmeta Crusoe processor. Then the on-chip LI cache, that is also very high compared to other x86 architectures. Then L2 cache, that is 256. It is very high compared to other architecture. Then die size. See here the die size is very less. Means that the chip area is very less in Transmeta Crusoe processors. Why the chip area is very less in Transmeta Crusoe processors? Means the complex hardware is replaced with a software. We will see that one. What is the complex hardware that is replaced with a software. This is the advantage in Transmeta Crusoe processor. And there is another. See here, and according to the sizing, it almost decreases 50% compared to the other x86 architectures. The Transmeta Crusoe processor will decrease the size, reduce the chip size to 50%. And we have another advantage, that is in general other x86 architecture the temperatures rises to 105 degrees. When the chipset in operation, at that time the temperature is rises to 105 degrees. It is very high temperature. In order to decrease the temperature, we are using coolants. We are using separate coolants. The coolants will reduces these temperatures quickly. 105 degrees temperature reduces very quickly. That's why we are using coolant in other x86 architectures. If there is no coolant, it may be, or it can be chip damage. That's why we are using coolant in x86 other x86 architectures. But in transmitter Crusoe processor, the temperature is about 48 to 45 degrees centigrade. Means it is very low compared to other x86 architecture. Here we didn't use the coolants. When you use the coolant means the chip area will be increases. When we doesn't use this coolants in x86 in transmitter Crusoe processor architecture. That's why the chip area is very less and the power consumption is also very less. Okay, that is the main difference between the other x86 architectures and transmitter Crusoe architecture. The main one is the other x86 architecture, the temperature rises to 105 degrees. Here for a transmitter Crusoe processor, the temperature is about 45 degrees centigrade. For that we are using coolant in x86 architecture in order to decrease this 105 degrees centigrade to decrease to low. In the transmitter Crusoe processor, there is no use of the coolants. When you use the coolants, the chip size is increases. That's why the other x86 architecture, the chip size is very high. See here the die size is almost 130, 108 and 106. But here in transmitter Crusoe processor, the size is 73. Why this is 73 means here we didn't use any coolants. Okay, this is the main advantage of transmitter Crusoe processor hardware. Then we will see the software. See here, this is the block diagram of a transmitter Crusoe processor software. See here we have different other softwares. This outer layer is built with a high level software. The dot software is nothing but BIOS means basic input output software, operating system and other applications. This is a high level software. And we have VLIW engine. It is a mission level language software. See here in between high level software and mission level language software, we have code morphing software. It acts as a interface in between the high level software and the mission level software. Mission level language and the high level language, we have a interface, that is code morphing software. The high level language doesn't interact directly with the mission level language without support of code morphing software. The code morphing software translate this high level language in mission level language. At the time only the interaction between the high level and mission level will be and the hardware engine will be established. Without code morphing software, there is no direct contact with the hardware engine. That is the main thing in software section in transmitter Crusoe processor. And the code morphing software has a written option in any modifications required in VLIW engine. The modifications is done by the code morphing software. Means any written data is done with respect to the code morphing software. But the outer layer means the high level language software doesn't interact directly with the VLSIW engine. That is the main difference between the main difference between the general VLIW engine instructions and the general x86 architecture. This outer layer is nothing but x86 architecture instructions. This inner layer is VLIW instructions. In between we have code morphing software. Let us take an example regarding code morphing software. Generally in laptops or mobiles we have kernel. When you see about or when you see the specifications of your laptop or mobile, we have a kernel baseband version something. That kernel is also same like of code morphing software. Means it is a interface in between the hardware and the software. Kernel is a interface in between the hardware and software. Similarly here also the code morphing software is interface in between the mission level instructions and the x86 instructions. Okay, this is the software block diagram. This is the architecture of the software in transmitter Crusoe processor. Then we will see some advantages compared to other x86 architecture. The transmitter Crusoe processor has some advantages and some other special functions. We will see those functions and those advantages compared to other x86 architecture. See here, the first one is decoding and scheduling. In general x86 architecture, the memory fetches the instructions fetches from the memory. In general x86 architecture, the instructions fetches from the memory and given to the translating it means thus instruction exercise instruction is transferred to the machine level language instruction and given to the dispatch unit. This dispatch unit is dispatches to the functional units. That is the operation of decoding and scheduling in general x86 architecture. But here in transmitter Crusoe processor we are using those complex hardware is replaced with a software that is known as code morphing software. In x86 in transmitter Crusoe processor we are using code morphing software instead of the complex hardware. That's why this code morphing software translate the entire instructions. Those translation instructions is saved in the cache. That is the main advantage when you do decoding and scheduling in transmitter Crusoe processor. For that the speed of the performance will increases and the power dissipation is also decreases in transmitter Crusoe processor compared to the other x86 architecture. We have a hardware in order to translate the high level language means x86 instructions into the machine level language in other x86 architectures. But here with in place of hardware we are replacing the code morphing software. In code morphing software fetches the entire instructions at a time and translate those instructions and saved in the cache memory. We already know what is cache memory. Cache memory is a very fast memory, very speed memory. The return speed and read speed is very high in cache memory. That is the advantage when you do decoding and scheduling in transmitter Crusoe processor. And also by using CMS software, by using code morphing software in transmitter Crusoe processors, we get high performance and low power. That is the advantage here compared to the other x86 architectures in transmitter Crusoe processor. The next one is caching. Already told that the CMS software translate instructions are stored in caching. The caching is nothing but a when the instructions are used repeatedly, when any instructions are repeated or operating repeatedly means the using those instructions repeatedly. At that time what happened, we need to fetch those instructions repeatedly. When that instructions is stored in the cache memory, at that time we will fetch the instructions very easily and in fastest manner. That's why the caching is very useful in transmitter Crusoe processor compared to the other x86 architectures. Here we have a caching means we have separate memory in order to store this repeatedly used instructions. Those instructions are caching, those instructions are fetching very easily when you use the caching. Then the next one is filtering. Filtering is nothing but we have software code. In the software almost 100 to 1000 lines of coding is there, but according to the functionality we require a particular code in that 100 to 1000 lines. According to the operation we need to get a particular code. In order to get a particular code we need to fetch a particular code. That is known as filtering. Means the software is filtering and then get a particular code according to the operation. That is the filtering. For filtering in transmitter Crusoe process we have a separate module. We have a separate module in CMS software. That's why the filtering is very easy in using transmitter Crusoe process. Do you understand what is filtering? For a particular operation we need a particular code in the total software. For a particular operation we need a particular code in the total software. That's why we need to filter the software and grab the particular software in the total software. That is the filtering. In filtering, the transmitter Crusoe process do filtering very fastly means it has a separate functional unit in code morphing software for filtering. That is the advantage in transmitter Crusoe processor. Then prediction and path selection. In transmitter Crusoe processor we are using a feedback path. See here, this is the feedback path. This x86 instructions is doing any condition. There is a no at that time. The software is going to the code morphing one. There is yes, then again there is a feedback path. This feedback path is used in transmitter Crusoe processors. That's why the prediction and path selection is very easy. Means if you need a particular code, we need to predict and we need to select that path perfectly. This path that selection is very easy when using the transmitter Crusoe processor other than other x86 architectures. These are the advantages compared to other x86 architecture. First one is decoding and scheduling, the second one is caching, the third one is filtering, and prediction and path selection, the fourth one. These are advantages. This is the content in Transmeta Crusoe processor. In that, first we will see the why we are using the Transmeta Crusoe processor, what are the advantages. Then we will see the hardware part, then we will see the software part, then we have some advantages compared to x86 architecture. These are the advantages. That's it for Transmeta Crusoe processor.